Hello, I'm Matthew Kahn, and I'm a professor of economics at USC. And Professor Amin Ouazad and I, in this video, are going to speak to you about our ongoing research on the mortgage finance market and our continual learning.
Thank you, Matt. I mean, this was really an important subject that we wanted to study. We wanted to write a paper that helps in the design of public policies in the mortgage market. And so we published a paper called Mortgage Finance and Climate Change, Securitization Dynamics in the Aftermath of Natural Disasters, published in 2022. And in that paper, we present a range of evidence suggesting that lenders are transferring climate risk to the government-sponsored enterprises in the aftermath of hurricanes. Now, in 2023, authors from Cal State University, Simon Fraser, and the University of Pennsylvania published a comment called Adverse Selection and Climate Risk, a Response to Ouazad and Kahn. And they argue that there are two issues in Ouazad and Kahn, that there should be changes in conforming loan limits, and there are issues with the rounding of dollar amounts of loans. And they argue that when this is corrected, our results vanish. So in this video, we are presenting evidence that this comment has very significant issues. But we'll let you decide, make up your mind about this, because it's really important that you are able to get access to the same evidence that everybody else has, because we've been very transparent since the very beginning. We posted our data in December 2021. We made it available to researchers in August 2021, so 4 months before it was posted on the RFS Dataverse. And so it's been really important to have a public debate about this. I think scientific discourse is really important. And that's what we want to do in this video. And so after this video, our goal is that you are able to go onto the RFS Dataverse and onto a GitHub repo of our code, and that you're able to run the same code as we have and inspect the evidence. And then you can decide for yourself what the causal treatment effect is. And we don't think it's the final word. We don't think our paper is the final word. Of course, science moves one funeral at a time. And I think it's really important that the constructive dialogue about this issue continues. All right. So before mentioning this evidence, we wanted to just have a look at one affiliation of one of the authors, Michael LaCour Little. So he states that his affiliation is California State University, Fullerton, an academic institution. So we downloaded his resume. We redacted his home address. I think it's important. It's not really about this information. I think it's just a small fact, which is that if we look at his tenure at Fannie Mae, it ended in January 2023. And the author submitted his comment in February 2023, so just a few weeks before submitting the comment. And he states that his affiliation is California State University, when we can see from the CV that he retired from Cal State University Fullerton in 2021. So I'm not saying that this definitely proves anything, but I think it's important as part of the conversation. It's also important as part of the rules of COPE, an association that looks at ethics in research, to declare explicitly what conflicts of interest there could be. And so I'm asking a question: is there a conflict of interest? And I think we can decide for ourselves. But I think it's important to separate this from the scientific evidence we're going to present later, because the scientific evidence that we present later is it's it, it's something you can verify yourself. You can download the data, you can look at. All right.
So Amin, I'd like to jump in there. Did we receive funding for our research? And as we did our work and continue to do our work, do we view ourselves as having an adversarial relationship with Fannie Mae?
No, honestly, I think, you remember that we in fact started this research by calling Fannie Mae in 2016. Um, and we clearly said, we are interested in climate change and mortgage credit. I think it's an exciting area of research. And I think it's somehow unfortunate to, that this should be adversarial. I think we've had very constructive conversations with Freddie Mac, with FHFA, and I really thank the economists at these institutions, because I think the way forward is to try to build a consensus. The mortgage market is very large. We're talking in the tens of trillions of dollars of outstanding debt. So it should be in the interest of every American taxpayer to look at these issues. And so we look
I
forward to a constructive dialogue. Yeah.
And I mean, as you know, our original partnership here was both of us are deeply interested in the consequences of when one buys a home. Before I started working with you, I think I thought that when one buys a home, they just pay with cash versus in a world where most of us get a loan, of the crucial issue of the role of lenders as potentially the adult in the room when there are new risks like climate change, which we're all still learning about these challenges. And so through our collaboration, I've learned so much about how the specific rules of the game affect the incentives of lenders and the securitization decision. So I think there's many crucial public policy issues that we've been talking about for years now.
Oh, I fully agree. I've learned a lot from you as well. I think, when I contacted you, I had spent quite a few years working on featuring mortgage credit in urban economics models to try to understand the role of leverage. And I think it was a very natural collaboration to sort of see how work at the intersection of environmental economics and mortgage credit can be written. And so, this is a first order issue. And given that most houses are bought using mortgage credit, they play a very important role. So there are questions about G fees, about in the jargon of people doing mortgage credit, LLPA matrix, tools that Congress can use to nudge households towards safer areas. And I think it's really important to open the dialogue. So today we're going to present narrow replication questions. We're going to really look at the nitty-gritty of the data. But I think it's important to remember that there's a big picture conversation, which I think is above all of us. And I think it's a very important question. And we're only one part of a larger scientific community looking at these questions. We're going to give examples of 4 papers by prominent economists from reputable institutions who are working on these issues and who find similar estimates as us specifically. So in this video, what we're going to do is we're going to present first evidence that there are large numbers of missing data. Approximately 35,000 observations have missing data in the high-cost county dummies in the replication of LaCour, Pavlov, Wachter of Ouazad and Kahn. This large number of missing data is really problematic because it's concentrated in hurricane-exposed areas. We're going to show you maps and breakdowns that there's a lot of missing data in Florida, in North Carolina, in Virginia, places that have been affected by natural disasters. And we're also going to show you that it's likely the outcome of a failed join in outer join in MATLAB code. So I apologize for the broader public about the jargon here, but I think it's really important. If you are a graduate student today and you're doing applied econometrics, MATLAB is an outer join seems to be a very dangerous choice of software because it's much harder to do quality control, to check the output, and we'll see why that's the case. So we will see that it's probably a lack of experience and training of the research assistant who did the work. In the second part of the video, we're going to present evidence that there is arbitrary and selective addition and removal of observations that are hard-coded in the scripts. I cannot figure out why. These data are present in Ouazad and Kahn. We went back to our code line by line. We never found any line that adds or excludes arbitrary observations. We don't understand why someone would do that. We don't think it's the standard econometric practice. And I would encourage every MSc and PhD out there to never, ever, ever do that. And then third, because what's important is to show that our results replicate. We're gonna show that the results of Ouazad and Kahn replicate. The data has been and will remain available to the public. We've also made changes suggested by LaCour, Pavlov, and Wachter. Our results are robust and even improve when we apply these changes. And I want to be very clear here that there are timestamps. There's the RFS Dataverse of December 6, 2021, that shows that the paper is replicable. There's the GitHub archive of May 11th, 2023, and there's the GitHub archive of this month. I'll give you the link that replies to the August 2023 data. What's important is we're doing it now because we did not have access in May of last year to the RFS Dataverse archive of the comment. It's standard practice to provide data and code. This was not provided at the appropriate time. And then we'll present evidence from 3 prominent papers, one published in the Review of Finance, one R&R at the Journal of Political Economy, and one R&R at the Review of Financial Studies that concurs with what Ouazad and Kahn. I want to be very clear that these are not just mere citations. These are data analysis that provide consistent evidence for the climate securitization hypothesis. This is, we have I'm saying 3 prominent papers, but there's even more researchers who have looked at the same data. This is publicly available data. You can run it over a weekend, and you can look at these different hypotheses. So we're not claiming that we are alone here. We are part of a community. So I want to mention a resource that everybody can use, the GitHub archive, Ouazad Kahn 2022, that allows you can clone this repo, you can fork this repo, and you can run the code. One great thing about this repo is that it downloads the data automatically. So you don't have to do the grunt work of downloading one file at a time. It takes a bit of time to download, but once it's downloaded, it's easy to run the code. All right, so let's start with evidence of large numbers of missing high-cost county dummies, missing data in the LaCour, Pavlov, Wachter 2024 that aims at replicating Ouazad and Kahn 2022. So the first step is to go to the RFS Dataverse. There's a DOI, so this is a permanent link that you can click on, and you can click on Access Datasets. This is a 10 gig archive. It features 6 files. You have to install a software called 7-zip. And once you've done this, you get a list of files. And you can spend time reading these files. I think it's really informative. And today we're going to focus on 3 files. We're going to focus on generate regression sample.m. This is a MATLAB file. And we're going to look at table 7 and table 5 CSV, which are the estimation samples for the LLPW comment. So this MATLAB file, generate regression sample, creates a data set from Hamda that LLPW claim is identical to Ouazad and Kahn. I have to mention that we provided code to generate that sample. So this is an entirely new code that they wrote. And we don't know why they wrote an entirely new code, but we're going to see that it generates new kinds of errors in the analysis. So this regression input table 5 is the sample for table 5 of LPW, and this is the sample for table 7.
So, Amin, just to clarify again, as we get ready to give our presentation, your view on whether LPW is a replication of our study, you reject that claim?
Yeah, I mean,
yeah. What is your definition of a replication?
I think we discussed this at length together, and I think it's well established in the literature. We can look at the work of Hashem Pesaran, for instance, that a replication is about running the analysis with similar filters, identical code, and generating the tables of the paper. Here we're looking at something slightly different. We're looking at a new code with new filters, with new methods in a different language that yields different results. And so there's a real question as how can we reconcile the findings of this MATLAB code with our findings? And you know, I think you mentioned multiple times that we've really worked hard on reconciling these results with ours because it's really puzzling to see that there's a difference. And so we'll show you what our work has led us to conclude. It's really important that everybody does this work. Okay, so if we look at this file, table 5, table 5 finds the same result as Ouazad and Kahn, and table 7 finds a different result than Ouazad and Kahn. And so why is table 7, the sample for table 7, a problem when the sample for table 5 is fine? And here is a very likely answer. The very likely answer is that the high-cost dummy variable, so there are counties that are high-cost counties, which are counties that have a higher conforming loan limit, and LLPW claimed that we miscoded that. Now, it turns out that when they code that high-cost dummy, which says which county is a high-cost county, they introduced a mistake of generating non-values, which is not a number, for 32,000 observations. Okay, and this shows up only for table 7, which is the table that finds a different result than Ouazad and Kahn. So, you know, okay, so, you know, is 32,000 a large number, a small number? Is it likely to affect the estimation? Let's have a look at what we can find here. Now, these not a number values are concentrated in hurricane exposed areas. So the maps are taking time to load, but if we do maps of counties that are that have at least one non-value, what you see is that the largest number of observations with nuns is in Florida. The state with the largest number of nuns is in Florida. Then the second largest number is Virginia. And then we have Texas, Georgia. Harvey is a hurricane that affected Texas. All All right. Now, these are present in many counties across each state. So these are counties in Florida that have a not a number observation. And these are counties in Louisiana that have not a number of observations. So in Louisiana, which is one of the states of the US that has the highest frequency of hurricanes, the non-observations are pervasive. Let's then move on and see what we find. Where does the mistake come from? This mistake comes from a line in the MATLAB code for the file 02 generate regression sample.m on lines 55 and 56 of the LLPW RFS Dataverse of August 2023. This is the line that adds a high cost variable to the main data set. So I think, a piece of advice, I think, for the graduate students who are listening to us today is that outer joins in MATLAB are really error prone. MATLAB itself is not well designed to deal with missing data. Outer joins, whether it's in Stata, in R, or in MATLAB, are really error prone. And the code never checks what is the outcome of the merge. And that is causing very significant issues here. The other thing that I want to mention is that these non-values bunch at the conforming low limit. So the 32,000 observations are in great majority right at the conforming low limit. And in the paper associated with this video, we provide a graph that shows the bunching of not a number observations of non-observations right next to the conforming low limit. All right. So
I have to ask, could this have been caught from summary statistics of, is there a forensic clue that the authors could have seen?
Absolutely. In fact, if you allow me, I'm actually going to go to I'm going to go to I'm going to go to the GitHub for this video, and I'm going to show that it's relatively easy to do tabulations. You can just do a table of those non-observations. You can find that in the errors encoding of high-cost dummy, the R, and it's very easy. You can just download the table 7 sample, and then you can simply do a tabulation of the high-cost dummy variable using the table 7 sample. What's important is to make sure that the tabulation displays the missing data. And I think that's what the student missed when they did the tabulation. This is a fairly basic thing to check, but it's something that should have been done prior to launching the regression. So, so this is something that could have been prevented. And so we think that a good practice when doing regressions is to do descriptive statistics of the observations. So let's the next part is about the evidence of arbitrary data exclusion duplication in LLPW that replicates Ouazad and Kahn 2022. All right, so to do this, we're going to again go back to the Dataverse of LLPW, and we're going to look at the code generate regression sample.m. This creates a data set that they claim is identical to Ouazad and Kahn. We're going to see that's not the case. So when I read this code line by line, it's very important to you just print it, go to a cafe, read line by line, try to understand what's going on. And I found that lines 140 to 143 are are excluding a hard-coded list of zips. And we took that list of zips excluded, and we tried to understand why they're excluded. Why do they do that? There's a comment in the code saying, as in Ouazad and Kahn, we exclude those zips. We will show you that, and it is verifiable because there is the RFS Dataverse of December 6, 2021, that Ouazad and Kahn never excludes any of these observations. You can look at it yourself, line by line, look at our code. You will not find the hard-coded exclusion of data. So why do they do that? We don't actually necessarily have an answer why they exclude data. It's not good econometric practice. And we will show you it's very simple to test. You don't need to read it line by line, the code of Ouazad and Kahn. You can just look at the sample that we used. And in one line, you can check that these zip codes are never excluded from Ouazad and Kahn. They're actually part of the treatment group in Ouazad and Kahn. They're part of the zip codes affected by hurricanes. So what was the intent of this exclusion? We don't know. We think it's an issue. So how do you check in Ouazad and Kahn that these observations are in the sample? Well, you can go to the RFS Dataverse of Ouazad and Kahn, and the sample is there. It's sample classifier.rds. You can load it in R, and you can check that it's present. How do you do that? You read the file in R, and you do a table of whether these excluded zips are in the sample of Ouazad and Kahn, and what you will see is that they are in Ouazad and Kahn. The outcome of this line is that these zip codes are in Ouazad and Kahn. So we did not exclude those zip codes. They are exposed to hurricanes in Ouazad and Kahn, these observations. If we look at the list of 5-digit zip codes excluded by LPW, they are treated in Ouazad and Kahn, and perhaps more concerning is that they are affected by Hurricane Sandy in 2012. They're affected by Hurricane Katrina in 2005. They're affected by Hurricane Ike in 2008, Irene in 2011, Gustav, and Rita. So these are all part of the treatment group. And as we know, because this identification strategy looks at the conforming load limit, the results can be very sensitive to arbitrary data deletion in the sample.
So, Amin, just to pose that again, by deleting these zip codes, that research team sort of changed the composition of the treatment group.
Absolutely.
So I don't view that as a replication of our study.
Yeah, and we could say, okay, was this just a random exclusion of zips? We show evidence also that these are more likely to be zip codes in which are conforming loans. So loans that are purchased, securitized, guaranteed by the government-sponsored enterprises. So it's quite concerning, in fact, that these would be excluded from the analysis. And on line 134 of the same script, generate regression sample.m, you can see that they excluded a specific respondent ID that is 41-1795868. The Honda nerds who are listening to us, I don't know how many Honda nerds there are, but know that respondent ID is the identifier of a lender. And I did research to understand what is the lender behind 41-1795868. And we found that this is a lender called Ditech. Why was Ditech excluded? We can only speculate at this moment. And I think it's very important to be cautious here. But if you click on the link and you go to the website of Ditech, Ditech filed for bankruptcy in 2022, is involved in a number of lawsuits, and that's all we can speculate. But it is quite concerning that DITEC would be removed from the analysis. This lender is in the sample of Ouazad and Kahn 2022. It is in the sample for all of those years. This is the website of DITEC, where the bankruptcy court entered an order governing the distribution of any unclaimed borrower funds remaining in the DITEC estate. I'm putting here a question mark. I'm not making a definitive statement, but I just find that surprising. You can again verify that DITEC is in the Ouazad and Kahn sample, and we invite everybody to do that. So we've reached a point where we've seen major issues in joins of the data, and we've seen arbitrary data inclusion, exclusion, and so we wonder where that is coming from. Would an experienced team do this? We received an email on February 10th, 2021, from a person called Carl Coopers, who said that he's a researcher at Simon Fraser University working on a project relating to climate risk. And he said that he would like to explore some of the findings. And he said we wanted to further explore specification 1. So, I mean, the question here, I mean, you can see that the author is an MSc. We have evidence that it is likely this MSc student has written the entire code for this archive. It's likely because the RFS Dataverse code was uploaded by Carl Coopers, and we received multiple emails from Carl Coopers, although we cannot definitely say that he was the only individual involved here. When I read further explore specification 1, I don't know if you agree, Matt, but I'm wondering about a pre-analysis plan. I don't know. I mean, you know, it's possible to p-hack replications, and I mean, is this the first instance of a p-hack replication? I don't know, but it is possible, and I think you know, yeah, there's a question here.
So I mean, let me pick up there. I'm older than you, and let me say that in my long research career, which now is almost 35 years old, I don't remember a previous case in my research when other research teams were entering the fray before a paper had gone through peer review. So in terms of timing, we released this NBR paper, and then we knew we were working on something very important. And I've never experienced something like this before. Have you ever received an email like this of this?
I mean,
I'm trying to decide. I can't remember my thinking at the time when we received this, but I've never experienced a situation like this before.
Right. I mean, we've been really open. In fact, we were, I think, in the second round of revise and resubmit at this stage. We disclosed the data and code in August, and we published it in the RFS Dataverse. We, in fact, you know, have been very open about this. Yeah, I mean, it's interesting. I don't know what to make of this, but I find the exploration aspect a little bit worrying because, you know, we learn in statistics that all of the critical values are correct when we decide on the specification and we stick to it. So you know, that's a question. And if we read the email, we can see, you know, I'm wondering if you may be willing to share the relevant crosswalks and possibly also the programming scripts that were used to generate these figures and the regression specification 1. We've provided all of this. If you go to our RFS Dataverse, there's a zip code, zip file called workflow. And we actually believe that this has been used by a number of researchers in the last few years, because that code, for instance, includes the parsing of Atlantic hurricane data to build the wind speed cones, It's the code also provides an analysis of elevation data, which is also quite a bit of work. We've spent months processing the data. So there's a lot of sweat equity there, and we've provided this sweat equity to a lot of researchers, and we're happy about this. I think it's really important that we're researchers because we're providing a public good. But as we mentioned here, he was able to access it, but did not use the code. If he had waited just a few weeks, he would have seen that he was able to download the code and run it. So there isn't a sense of urgency here that I'm wondering about. This is the LinkedIn profile of Carl Coopers, and as we can see, this limited experience of large data projects, and that's all I can say here. This suggests the importance of learning good data practices in the PhD program. I think joins, we neglect joins, but joins are really an important skill. There's another table in LPW 2024, which is table 8 of the published comment. Now, there's something here that is an issue, which is that this was not uploaded to the RFS Dataverse. This is not in the LaCour, Pavlov, Wachter Dataverse. This is an issue because we need to see what the code is for that table. The only way we could do it is that Andrei Pavlov provided an archive earlier in April 2023, which seems to be consistent with table 8, but we cannot ascertain for sure. But as you can see, there's a reason why this code for table 8 was not disclosed. And the likely reason is that there's major issues in this table 8. It uses a very different event study design where areas can be hit simultaneously at the same time in different years. We store this in the cloud, so you can actually download this table 8 data if you type this URL in your web browser, and you'll be able to see the same result. This is also in the GitHub that we provided, which allows you to smoothly rerun the analysis of Andrei Pavlov.
I mean, I need to jump in and ask for a clarification there.
Yeah.
At the review of financial studies, is there a data editor who has responsibility to make sure that there's a one-to-one mapping of files and data generating the tables? So again, in there, it is the case that in their RFS archive, there is not such a one-to-one mapping.
Yes, not yet. There is not yet a data editor. It's gonna come. I think this is one instance where we need a data editor, and I don't think we need a data editor necessarily to police everybody, but we need a data editor to know what the standards should be and what the standards are, so that the data editor structures our workflow and that we make sure that we have homogeneous practices when dealing with data. And here we don't have a data editor for the RFS, and that makes things much harder. And for instance, it allows the LPW team to publish table 8 without corresponding code. We present easy to verify evidence that the data set is severely malformed.
I mean, that is a strange word. I know that we are both of American descent. What does the word malformed mean?
Well, there are significant issues in the way the control group and the treatment groups are built, in the sense that we will see that for some hurricanes, the treatment group is very long. For other hurricanes, the treatment group and the control group are very short. Treatment and control can have different time length. But also, a first hint of this is that you can have one observation where time plus 4 and time plus 3 are equal to 1 at the same time, which is puzzling because we can only be treated in +3 or +4, not at the same time in +3 and +4. We also see that there's a large number of treated observations with no time dummy equal to 1. So how can we beam the sample without a relative number of years? It is something that I cannot understand. A first hint that something is amiss is by looking at table 8 of the independent implementation results. This is something you can see in the published comment. And you can see that if you look at the placebos, so these are placebo coefficients for -2, -3, -4, you can see that a very significant number of them are large. So if we plot the event studies, you can see that there's a downward trend in those coefficients. A good design has comparable treatment and control. This is not the case here. And this is far beyond what would be expected if this was random, because with a 95% confidence interval, we should have 5% of the observations that are significant. So that would mean at most one coefficient significant. Here we can see that in columns 1, 3, 4, 6, 7, 8, and 9, the placebo coefficients right before the hurricane are significant. And that really casts doubt about the interpretation of the post-hurricane estimated impacts. If the treatment and control are not comparable, it's hard to interpret what we see after the hurricane.
And Amin, just to reiterate your point, these are not our estimates. These are the estimates reported in their published reply.
Mm-hmm.
And so I think that that's a very important point to point out. So thank you.
Yeah, I'm a little puzzled because I'll be honest with you, this is a table that I would look at with a lot of concern for the analysis. I would think that something's off with the design of the quasi-natural experiment. So of course we don't have a full RCT, we don't have a randomized control trial, but we do need a quasi-natural experiment to understand, to interpret the post-hurricane dummies. So we can also see, as mentioned earlier, that in the treatment group, there is 93,000 observations without any time dummy equal to 1. This is the treatment group. This should have time dummies equal to 1. They do not include time dummies beyond +4 and before -4. There's 6,000 observations where 2 time dummies are equal to 1 at the same time. So we're supposed to be treated in your +1, your +3 at the same time. And then there's 161 observations where 3 of the time dummies are equal to 1 at the same time. In the literature on difference in differences with multiple treatments at different times is a very deep and very interesting literature. And I think that it's fascinating to explore this. But certainly this is not a design that complies with the best standards in difference in differences. And that causes a very significant issue, which is that the treatment years are miscoded because of that. So we can see this by analyzing the treatment years, focusing on the hurricanes such as Francis in 2004, Charlie in 2004, Ivan in 2004, Jean, Denis, Wilma, Katrina. In the 2023 reply, we provide the other hurricanes as well. What you can see is that the number of observations is fluctuating wildly, but also that Francis, that happens in 2004, has observations for whom the treatment year is 2016. So we provide code to show that, and you can verify this. There are hurricanes with no observation at all. Charlie 2004 has no observation. Dennis 2005 has no observation. Katrina has 4 different treatment years. 2012, 2008, 2004. And what's probably happening here is that some areas are treated multiple times, and therefore Katrina is picking up hurricanes that happen later, but it is made in a arbitrary fashion because there's no rule here to attribute observations to these hurricanes. It's likely due to an incorrect event study structure that they designed. These are the other hurricanes. And you can see that, for instance, Irene has 3 different treatment years. Sandy has 2 different treatment years. Isaac has 3 different treatment years. And so
I want to jump in again because I naively thought that a replication exercise uses the same data and the same econometric specification subject to making, perhaps adding covariates, checking functional form. This doesn't sound like an econometric replication. It is the case that they changed estimators and claimed that they were replicating our study.
maybe in a broader sense, this is a replication exercise. But I think what's important is, if we run 1,000 different specifications, I think they do say in the comment that they run 1,000. Well, not every estimate is interpretable, because if the quasi-experimental design is incorrect, then we cannot interpret these results. So it's very important to do replications, even in a broader sense, with no pre-trend, with likely causal estimates of the impact of hurricanes. And so one way to do this, for instance, would be to compute f-tests of pre-trends and to keep those designs that have f-tests that are not rejecting the null hypothesis of the absence of pre-trends. On top here, we have a design here. On top of this, we have a design here that, fails a very basic tabulation. Yeah, it's concerning. In fact, I'm saying unfortunately, because I do think that this question deserves a proper treatment. The miscoding of treatment years also peaks at the conforming low limit. The same way that the non-values or bunching at the conforming low limit, here they again peak at the conforming low limit. So if we plot, for instance, for Hurricane Katrina, the share of observations with incorrect treatment year, this is not classical measurement error. This is measurement error that is bunching at the conforming low limit. So it's very likely to confound their estimates of the impact of hurricanes on the bunching at the conforming low limit. So this is not classical measurement error. Again, the exclusion of zip codes was also focusing on the Hurricane Katrina zip codes. Is there a pattern here? I'm putting a question mark. I don't know what was the process, the thinking process here, but it seems to be a sort of a systematic type of error that bunches at the conforming low limit, affects hurricanes, major hurricanes in the sample. There are other issues. Census tracts change boundaries over time. Now, there's very good established practices for dealing with this. Cardmass and Rothstein's QJ in 2008 used the geolytics data. We discussed this at length in our research conversations. But in LPW on page 37 of the Internet Appendix, they say, to do so, we match the census tracts in the earlier and the later census by the largest share of population. This is really unfortunate because on top of my head, again, we don't have the RFS Dataverse for Table 8. On top of my head, I would say that up to a third of the census tracts could possibly be lost because of this incorrect matching. If we want to, if we don't have money and we don't want to buy the geolytics data, and I'm saying this to graduate students out there, you can do it using census tract relationship files provided by the US Census Bureau. So it's possible to actually do a good job with census tract relationship files. If you want the link, send me an email and I'll send you the link to the US Census Bureau website they don't do this. And again, I think it's a reflection of the lack of training of the research assistant. If we want to get into the nitty-gritty of things, tracts can be split when there is increased population. A tract can be split into two different tracts, and it's the last two digits of the HAMDA census tract identifier that changes. And if we mess up the match on this, we can get very bad results. I think a lot of people who listen to us who've used census tract level data have seen this type of error happen. This is one of the most important things we want to teach our students working with census tract data. All right, now let's move to Ouazad and Kahn 2022. So we provide multiple sources that allow you to check Ouazad and Kahn 2022. We provide the RFS Dataverse. Since December 6, 2021, RFS readers have access to an archive with data and code. Since May 11th, 2023, the broader public has access to our turnkey GitHub archive. You can run the analysis, you'll get the results of Ouazad and Kahn. And we've just provided a new GitHub archive to make it even easier to download the HAMDA source data and generate the tables.
Amin, I want to briefly ask you about May 11th. At that date, what did we not know when we created that GitHub?
Yeah, they didn't give us access to the code for their table 5 and table 7. So we could not actually check their replication exercise. And in particular, I think it's unfortunate because we could have prevented the large number of missing values in the high cost dummy. We could have helped the research assistant, but they withheld that source code. Instead, they gave us an archive that we think is the archive for table 8, which is an entirely different exercise. And so we base our reply on the April 2023 source code that was provided by Andrei Pavlov that was not uploaded to the RFS Dataverse. So it's only after August 2023 that we could look at this. The thing is, we could not suspect that the code had dramatically changed. So we did not notice this immediately, that the RFS Dataverse was an entirely different set of code and data. We've done this, and we provide a working paper that analyzes this. We'll also provide an updated GitHub archive where we analyze the work. And you don't have to believe us. The GitHub archive I provide downloads the RFS Dataverse using their DOI, their permanent link. All right. So they make 2 points in LaCour, Pavlov, and Wachter. One point is that there is geographic heterogeneity in the conforming loan limits of high-cost counties. And second point is a rounding point. They argue that HAMDA loan amounts are rounded to the nearest integer, 1,000 integer, which is true. And they say that conforming loan limits should be rounded to the nearest integer. So they should be rounded up when the conforming loan limit is above $500. That is, say, for instance, between 417,500 and 418,000. They argue that in that case, the conforming loan limit should be rounded up. So let's look at these 2 points. First one, for high cost limits, we can see that counties that are high cost counties are located mostly in the west of the US, but there are high cost counties in the tri-state area. There are high cost counties in Virginia, on the Atlantic states on the northeast of the US, and Maryland. And we can assess whether using this heterogeneity affects our results. The short answer is it actually helps us to get better limits in high-cost counties. So it replicates well, Ouazad and Kahn. Again, we provide the code for this, so you don't have to believe us, you can run it. You can see that there's an increase in approval rates, there's an increase in origination rates, there's an increase in securitization rates. The economic significance is quite large. And one of the things is the closer to the limit, the better the results, in fact, because it's really the bunching and the conforming the limit that's important. And thanks to this suggestion, we can even run analysis with narrower windows. We can run the analysis with 4 plus minus 4%, plus minus 3%, plus minus 2%. And here we thank, in fact, LPW because our results are significant, economically and statistically significant. When we get to 2%, it becomes a little bit weak, but we can see that for 3%, the results are strong and the magnitude is large. In fact, plus 18.7% for the securitization probability is a large number. I also want to mention that this is the specification 1 of Ouazad and Kahn 2022. It includes year fixed effects, 5-digit zip code fixed effects, disaster fixed effects. Here we report only the interaction of below conforming loan limits times treated times the time dummies, but you can look at all the coefficients by running the regression using both the RFS Dataverse and the GitHub archive.
And Amin, just to reiterate that point, in the last 2 tables we've shown our viewers, this is a narrow replication exercise. Same data, same econometric framework as in our published 2022 paper of, I believe, respecting the literal definition of the word replication.
Yeah, absolutely. We follow LPW in saying use the heterogeneity of high-cost county loan limits. We use specification 1 of Ouazad and Kahn 2022, and it's a narrow replication exercise, and so we think that researchers can build on this and do more analysis. So we can draw graphs of the event study design. We can see the rise in the approval probabilities for the conforming market on the left, for the overall market on the right. And we can see the rise in origination probabilities, and for the conforming loan segment on the left and the overall market on the right, consistent with the hypothesis that there is an increase in origination probabilities in the conforming loan market and a decline in the overall market, which includes the jumbo market. We can see that the securitization probabilities are also increasing. So we can see that's true for the conforming market, for the overall market. And you can generate those figures using the archive as well. So the second point of LaCour, Pavlov, and Wachter is that because loan amounts are rounded to the nearest 1,000 in HAMDA, there is an issue, and we're going to see the fix. So let's start with page 12 of a document called 2013 Guide to HAMDA Reporting, Getting It Right. This is really getting into the weeds of HAMDA. They say, report the dollar amount granted or requested in thousands. For example, if the dollar amount was 95,000, enter 95. If it was $1.5 million, enter 1,500. Round to the nearest 1,000. Round $500 up to the next 1,000. For example, if the loan was for 152,500, enter 153, not 152. But if the loan was for 152,499, enter 152. So there's a rounding to the nearest 1,000. We all agree on this because it's in the HAMDA reporting guide. One thing I want to mention first is $1,000 is approximately 0.2% around the window at $417,000 and 0.1% at the current limit of 766,550. So, we have to compare this to the windows we use, which are 20, 10, 5, 4, 3, 2. The solution of LaCour et al. Is where we disagree, because the solution of LaCour et al. Is to round the conforming loan limit to the nearest thousand, and to compare the rounded loan amount to the rounded loan limit. The claim of LLPW is that this eliminates misclassification. We argue that in our approach, we have classical measurement error. There are errors on the upside and on the downside. In LPW, there's systematic non-classical measurement error on only one side. Why? Because there are two types of misclassification in HAMDA. One, there's true jumbo loans that should be a conforming loan. And there are conforming loans that should be a jumbo loan. So the LaCour et al. Address type 1. That is, they classify jumbo loans as conforming loans, and they classify and they shift observations to the left. But what we argue is that this increases the second type of error, the type 2 error. Our solution is agnostic. We do not alter the data. We do not change the conforming loan limits. We just compare the actual loan amounts to the conforming loan limits to the dollar. So in our case, there will be both type 1 error and type 2 error. This is likely to be classical measurement error. Let's take an example to see that their fix leads to non-classical measurement error. Let's take Collier County in Florida. The limit was $450,800. In HAMDA, loan amounts are rounded to the nearest thousand. So they suggest that the limit should be rounded to 451,000. Now, you can see immediately that it's going to generate a problem with the classification of the loans. The loans between 450,801 and 451,000, which are true jumbo loans, are wrongly classified as conforming in their analysis. And they don't report this. They're wrongly classified as conforming because as they rounded up the conforming loan limit, these loans in that segment become conforming loans, which leads to better pictures of the discontinuity. But it leads to a systematic misclassification of loans. So their approach yields systematic type 2 misclassification while eliminating type 1 error. So they provide in their published comment evidence of type 1 error in our work, but they never provide a figure of the type 2 error, which affects their work very significantly. And so they systematically bias the coefficients because they only have one type of error, which leads to more of these conforming loans in their analysis. It's also important to realize they use a weak inequality, lower or equal, rather than a strict inequality, because it can lead to a different classification. So is the LaCour comment overall making mistakes that tilt results in a certain direction? The non-high-cost dummies are significantly more likely to be in the conforming segments and in hurricane-exposed areas. They bunch at the conforming loan limit. The rounding fix biases coefficients and it replaces classical measurement error by non-classical measurement error. The independent replications event study design biases coefficient downwards. I think Matthew had a very good intuition for the fact that when they use their event study design, because they have control observations are part of the treatment, that means that some of these coefficients are biased downwards. You get the estimates are essentially trying to correct for the incorrect event study design. So I wonder, are results based on input or on good-looking outputs? And to talk about Andrew Gelman, is the garden of working path random or is it strategic? I'm putting here a question mark because I don't know the answer to this question, but it is certainly something that needs to be looked at. There are a number of papers looking at the climate securitization hypothesis. High-quality papers from economists. in the Fed system, at Columbia University, at Harvard Business School, at the Richmond Fed, that look at this issue in peer-reviewed journals.
So, let's go back a slide.
Yeah.
And let's see if we agree, and I know we do, on the definition of the climate securitization hypothesis. Yeah. And we coined this term, and to throw out a definition here, we view this as an umbrella of research of independent scholars using independent data sets, exploring whether the hypothesis that it is valuable to hold a real option when faced with the known unknowns of climate change, that it can be valuable to hold a real option, to issue securities, to have the option to be able to securitize to the GSEs, given the current rules of the game. So, can I ask you to tighten that up? We've created this term climate securitization hypothesis, and I don't think it's as well known as other claims out there, but it's an important claim.
This is important because it can be estimated with different approaches, different econometric approaches. For instance, in those different papers, they look at different mechanisms. Back in Senedal, in the JPE, R&R at the JPE, they suggest that pessimistic agents about sea level rise take on more leverage loans when the collateral is risky, but then they find that this impact is larger in the conforming loan segment, where banks can securitize loans and sell to the government-sponsored enterprises, than for the non-conforming loan segment. So you can see a table in their paper that shows these coefficient estimates, that there's more leverage in the conforming loan segment in places where households expect that sea level rise is going to affect their property. There's a paper published in the Review of Finance that finds that on average, lenders charge higher interest rates for mortgages in areas projected at risk of sea level rise. These effects are driven by long-term loans, but more importantly, and that's where this is related to our paper, they find that this premium depends significantly on a loan's eligibility to be securitized by Fannie Mae or Freddie Mac. The SLR premium is significantly higher for jumbo mortgages. Those are not securitized by Fannie and Freddie. So the pricing of sea level rise risk is stronger for jumbo mortgages, where there's not the securitization option that you mentioned. And I think it's an exciting avenue for future research to look at what's the dollar value of the securitization option. So you can see this on table 8, page 1538 of the published paper. And then there's a third paper, which is R&R, the Review of Financial Studies, that shows how mortgage lenders transfer flood risk to the government and underinsured households by taking advantage of strict flood insurance coverage limits and staggered flood map updates. They find that there is an impact of flood risk on leverage, but only when a mortgage is either privately securitized or held on the balance sheet. It's on figure 3 of the December 2022 version of the paper. And so that means that the response of LTV only happens when a loan is in the private securitization market, or the PLS, the private label securitization market, or held on the balance sheet. And there's no response of leverage for government guaranteed mortgages. So there's a common mechanism for these 3 papers that is consistent with the climate securitization hypothesis. We've also had conversations with researchers in different agencies that have estimated the impact of hurricanes and sea level rise on the securitization of conforming loans, and they suggest that they found a number of evidence that is consistent with our hypothesis. So I think it's exciting to see that there is a community that looks at this. But I also, and I think perhaps paraphrasing you, Matt, I think there's no reason that these effects are not going to go away over time, because we now provided information to the lenders and to the government-sponsored enterprises, and we hope that our research has had an impact on those securitization standards. And so actually it would be good news that we would be the Paul Revere's of climate change. So what are the takeaways? We sparked a literature that supports and significantly expands the paper's main findings. And we built on the shoulders of giants. I mean, there was an extensive amount of literature on selection into the conforming loan segment. In our quest to understand the dynamics of mortgage markets, we learned from the critique, from the comment on how to improve our estimates. We get better pre-trends. We get more significant results when we are in this narrower window around the conforming loan limit. But one of the things we learned from the comment is that delegating work to students without oversight can lead to risks. It's challenging. I think I think all of us, when we start our first job as assistant professor, and I don't know if you had this feeling, Matt, but first year assistant prof, I thought the research assistant will perform the analysis, and I will just stand back and wait for the results to come. In fact, what we learn over time is we need to be very much involved in the process of estimating our results and building the data. And so we also need to keep up with the best practices. MATLAB was a poor choice for building the data. And so this is the Paul Revere point. We want to change these securitization practices, and the Lucas critique applies. Our paper could have an impact on those securitization standards. And I'll finish by citing LPW. None of our results calls into question the value and importance of the Ouazad and Kahn model as a test for adverse selection. The question addressed and the setup of the test are important and should be replicated over time. So we hope that the contribution of the paper is not limited to the narrow replication, the narrow estimation, and we hope that there will be more work on this question in the future.
Amin, thank you. And I've learned so much from you and have been amazed with your ability to lock in this sort of forensic accounting of the code we were able to access. You have a power of concentration that I do not have. And so and we continue to do new work that we have an active research agenda here and are actively building on this foundation. And so without strutting too much, I think we become even more confident about the robustness of our results. And in this setting, as we wrote in these slides, these reduced form estimates are not laws of physics. It's capturing at a point in time these estimates of causal effects, and we stand by what we have generated, and we invite open debate, but it has to be a fair fight where we've shared our code and we want to see everyone else's. And Amin, is that a fair point?
Oh yes, and we're excited because we're gonna present new work at FHFA in November. We're going to present, we've presented the work at Freddie Mac twice. We've had a very constructive dialogue with FHFA and Freddie Mac. And we have a new paper called Adaptation Using Securitization, which is a paper that provides tools for securitizers to build better portfolios of mortgages that are more resilient to climate risk. And we think that all the workhorse tools of finance are useful for building portfolios that are resilient to climate change, even as temperatures increase according to IPCC scenarios to 2050. And so we really look forward to a robust dialogue also about this paper. And we hope that we can improve securitization and tranching practices in the MBS market. Thanks, Matt, because I've also learned a lot from you. I think this has been a productive collaboration, and I look forward to an impact on public policies.
Thank you, Amit.
Thank you, Matt.